Okay, so we're looking at the binomial theorem stuff now. So this is what we use when we're trying to multiply out a binomial, which means I've just got two terms that are being added or subtracted, and I'm taking that to a power. Like your example was x minus 3 to the 4th or something like that?
Yes.
Right. So instead of an a, you had an x. Instead of a b, you had a minus 3, right? Instead of n, you had 4. Okay, so the way we do this, we always are just going to build Pascal's triangle. And once you build it, it's the same every time. It's going to be this triangle, and what you're going to end up with is along the left edge of the triangle and the right edge of the triangle, you're just going to get ones, okay? In between that, you're going to get different numbers that are built by adding the numbers above to the left and above to the right. Notice the arrows here. If you're starting from a 1 and you're scooting down to the left or down to the right, there's only one number that you're adding up. You know, 1 plus nothing else is just 1. 1 plus nothing else is 1. 1 plus nothing else is 1, right? So you always get ones on the left and the right slopes of Pascal's triangle. But in between, when you end up having to fill a spot that's got numbers above to the left and above to the right, you just add those up, okay? So like from here, when we start at row 0 and we scoot down, well, this little cell right here only has one number above it. There is no above to the left. There's only above to the right. And so it ends up just being a 1. Does that make sense?
I think so.
Okay. This one right here, there's nothing above to the right. There's only a number above it to the left. And so that number just translates down again to this cell. Same thing here. When we move down to row 2, the left edge of row 2, there's only one number above it. There is no above left. There's only an above right, and that's a 1. So those always end up being 1s because you're only adding up a 1 plus nothing else when you're creating the left and the right slopes. But when we look in the middle, when we get down to row 2, for example, all of a sudden now we've got this cell in the middle here, this little empty spot, and it's got numbers above it on the left and the right. Okay, does that make sense?
Yes, it does. No, it's fine. I'll just go out to the table.
Oh, you're fine.
You know, I've got 2 other siblings who are doing other stuff too, so it's fun.
Oh no, you're fine, Haley. That's no problem.
Places.
No problem.
Okay.
Okay, so then when I'm building, pretend that there's no number in there for a second. In fact, here, let me just do this. I'm gonna be real tricky and play with my fancy toys here for a second. Okay. So there's nothing there, right?
Mm-hmm.
Okay, well, what's going to go there? Well, I just look up above it to the left and above to the right. I've got a 1 to the left and a 1 to the right. 1 plus 1 is 2. Okay. Whoops, I got to do one more thing here. This will be, we'll just kind of, oops. There we go. So I want to be on that guy. Just going to move him. So he's at the top there. There we go. Okay. So now what number is going to go there?
3. Because
3, yeah, because 1 plus 2 is 3, right?
Right.
Well, what number is going to go there? Well, 1 plus 3 is 4. What number goes there? 3 plus 3 is 6. See what I'm saying?
Yep.
And so you just keep on building your way down in this triangle. Like, for example, there, that would be a 4 plus 6 is 10. And you just, once you build the triangle, it's the same every time. Okay, now what does it mean, though? That's the next issue. What does it mean? Okay, so we call this top one, we call that row 0. The next one is row 1. The next one is row 2, etc., all the way down, okay? So what those are telling us is the number of the row is telling us the value of the exponent.
Okay.
Okay. So if the exponent is a 0, well then, for example, if I had x plus 3 to the 0, anything to the 0, remember, is just equal to 1, right? And so my answer is just going to be 1, right? If n was equal to 1, anything to the first power is just itself. So if I had x plus 3, or let's do it with a plus b for a second, and then we'll start adding x's and numbers in a second. If I had a plus b to the 1, well, a plus b to the 1 is just going to be a plus b, right? Well, notice that the numbers that are being multiplied by a and b in that case are just 1 and 1.
Mm-hmm.
Okay. So then what about like row 2? Well, if n is a 2, if I had a plus b squared, what would we get? I'm just going to write this down. Let me do this. I'm going to where's that little thing right there? Oh, come on. Here we go. Here it is. Okay. So if I wanted to do the quantity a plus b to the, oops. If I wanted to do a plus b to the 2, that's going to equal, well, look at the coefficients I get in row 2. I get a 1, 2, and a 1.
Mm-hmm.
So I'm going to get a 1, and I want to make that, is there a way I can make that red? I think so. Oh, why is it doing this? Well, maybe I can't. So there's my 1 that comes from that. I get 1 times a squared plus there's my 2. So I'm going to get a 2 times a times b plus, and there I've got a 1. So I'm going to get a 1 times b squared. Okay, so what I wanted you to see there is just that the numbers that we get in row 2, the 1, 2, and the 1 are showing up there, there,
Mm-hmm.
and there. Okay, now what about the rest of it? How did I get the a squared and the a times b and the b squared? Here's the rule. This is row 2. So we know that the exponents for each term have to add up to 2. So it starts off with all of the exponent power shifted to the first term, to the a. So I'm going to get an a squared in the first term, and then every time I scoot over to the next term, the power of a is going to drop by 1, and the power of b is going to increase by 1. Okay, so the next one, it's going to be a to the 1 times b to the 1, which is just a times b. And then finally in the last one, the a's disappear completely because they're to the 0 power now, which is just equal to 1. And the b's have ramped up to 2. So the a's start off with all the exponent power and the b's have none. And then every step to the right, every time we move to a new term, it just kind of equalizes and it just moves. So the b's increase and the a's decrease. Does that make sense?
Yeah, that does.
Okay. So then if we wanted to do something like a plus b to the 5th, so what's that going to do? Well, a plus b to the 5th, now we're going to go down to row 5 here. Okay, and in row 5, these are going to be the coefficients, right? The numbers that are being multiplied by the a's and the b's. The first term, it's going to be a 1. Second term is going to be a 5. Third term is going to be a 10. Fourth term is a 10. Fifth term is a 5. Sixth term is a 1. Okay, and then all I've got to do now is figure out, okay, what are those being multiplied by, right? So in the first one, it's going to be a to the 5th, right? So I'm going to get 1 times a to the 5th. And if we come down here, I wonder if it'd be easier just to do it this way. Yeah, we'll try this. Okay, so I'm going to get 1 times a to the 5th plus 5 is my next coefficient, right? So 5 times a to what power?
The 5th, or no, the 4th.
4th, good. Okay, times b to the 1, right? Which I just write as a b.
Okay.
Okay, plus what number?
Plus b.
Well, now, okay,
it would be 10.
10, there you go, good. 10 times a to what power?
The 3rd.
The 3rd, there you go. Times b to what power?
The 2nd.
The 2nd, very good. Plus my next term, what number, what coefficient?
10.
10 times a to what power?
The 2nd.
The 2nd, good. Times b to what power?
The 3rd.
You got it, you're getting this. Okay, we'll just finish this though, because I want to make sure you get the last part. Now, then I'm going to do a different kind of problem. Okay, plus what's the coefficient?
5.
5. A to what power?
To the 1st.
To the 1st, so I'll just write it as an a. Times b to what power? Whoops. Times b to what power?
The 4th.
What did I do there? A, b. Oh, why is it doing that? Oh, because it thinks it's an absolute value. I got it. I got to put a little time sign in there. Oh, man. I'll just... Oh, I know what I can do. I can do this. B, there we go. B to the 4th, you said, right?
Yep.
Okay, and then finally the last term is plus, what's the coefficient?
1.
1, so I wouldn't write it. Times a to the...
5th.
No.
Or to the 1st times...
A to the 0 now. So it's gone.
Okay.
Right, and then b to what power?
The 5th. To
the 5th, there you go. Okay. So do you notice here then, when we do this, that there's a symmetry here, right? Like if I drew a line right down the middle of this, the A's and the B's are just, they're kind of interchangeable, right? They're all treated equally. The A's and the B's both get to be to the 5th power by themselves once. They both get to be multiplied by 5 to the 4th. You see what I'm saying?
Yeah.
Completely interchangeable. Okay, so now let's try doing one of these where, I'm not going to go through that stuff with you. There's a quick example, right? So now you can see, right, there's the Pascal's triangle, just those highlighted coefficients. That's what those meant, right? When we build that Pascal's triangle, it's just telling us the coefficients is all, right?
Right.
Okay. So what if we try to do something like, do they ever do any of these where they do like 2x plus 10 or 2x plus 3? Okay, so let's try 2x plus 10 squared. Okay, so now we're going to use the pattern a plus b squared, right? Well, in Pascal's triangle, that means because we're taking it, the binomial to the 2nd power, it means that we're going to be in row 2, right? So in row 2, the coefficients are 1, 2, and 1. So we already know we're going to get a 1 out front, and then a 2 times whatever we have in the 2nd term, and a 1 is the coefficient in the 3rd term. But instead of an a this time, a is equal to the quantity 2x. So wherever we used to be taking a to a power, now we're taking the quantity 2x to a power, right? So the first term is going to be 1 times a squared. Well, a is 2x, so we've got to square out the entire 2x. Okay, so that just means 2 squared is 4. So if we want to get an answer to that, let's go ahead and finish that one up then. So we're going to get So what are we going to get for that then? We're going to get
4x.
Yeah, we're going to get 4x squared, right?
Mm-hmm.
So 4x. You can see what I'm doing on your screen, right?
Yeah.
So we get 4x squared for our first term plus 2 times a times b. Well, a in this case is 2x and b is 10. So I'm going to get 2 times 2x times 10. So 2 times 2x is 4x times 10 would be 40x, right?
Mm-hmm.
So we get 40x for our second term. Okay, plus 1 times b squared. Well, b is 10. 10 squared is 100. So that's our answer. See what I'm saying?
Yep.
Okay. And what if we want to do something like this guy down here? Let's try this one. The quantity 10x minus 1 squared. Okay, so now that's going to fit the pattern a plus b squared, where a is equal to 10x and b is equal to -1, right? Because subtracting something is the same as just adding a negative, right?
Mm-hmm.
Okay, so we're going to follow the same pattern. So we're going to get a squared plus 2ab plus b squared from Pascal's triangle. So a is 10x, so I've got to square out the quantity 10x, square the whole thing. So I'm going to square the 10 and square the x. I get 100x squared for my first term. Then I've got 2 times a times b. Well, that's 2 times 10x times -1. 2 times 10x is 20x times -1 is -20x. So there's my second term. And then finally I get plus b, which is -1 squared. Well, -1 squared is +1. So there's my answer. Does that make sense?
I think so. It does. Yeah.
Okay. Does he have you do, he has you do cubes on there too, right? So let's try, I'm going to scoot up a little bit. Let's try one like that. How about like 10x minus 9 cubed?
Okay.
Okay. So first of all, we have to look at what our row 3 looks like in Pascal's triangle, because I'm taking my binomial to the power of 3, right? Well, row 3, if we go, I'll come right back to this, but if we go back to our Pascal's triangle, row 3 has the coefficients 1, 3, 3, 1, right?
Mm-hmm.
Okay. And so we know then that row 3 is going to look like that, isn't it? It's going to look like 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. Okay. What's our a and what's our b? Well, what's a in this case for our problem in the blue there?
10x.
10x. What's b?
-9.
There you go. Okay. So we get 1 times the quantity 10x cubed. So you explain to me, how do we cube out 10x?
You cube it.
We cube each part, right? We cube the 10 and we cube the x. Okay. So 10 cubed is 1,000 times x cubed. There you go. So there's our first term, 1,000x cubed. Okay, our next term we agreed was 3 times a squared times b. So I got my 3 times, and you told me a was 10x. So I've got 3 times the quantity 10x squared times -9. Well, 10x squared is 100x squared, right?
Yes.
Okay. So I get 3 times 100 is 300 times x squared times -9. Well, 300 times -9 is -2,700. So that was my second term, -2,700 x squared. And so on. Move to the next one. The third term in our triangle tells us we get 3 in Pascal's triangle is 3 times a to the 1 times b squared. So 3 times 10x times -9 squared. Well, when I multiply all that stuff, 3 times 10x times 81, it just gives me 2430x. And then finally plus b cubed. Well, B is -9. And remember talking about in class, if we take a negative number to an odd exponent, I should expect it to be negative, right? Negative number to an even power is always positive, but a negative to an odd is negative. And -9 cubed is -729 if we multiply it out.
All right, thank you.
Yeah, we can go through another one if you want. If you feel like you're good, that's fine.
I think I'm pretty good on that.
Okay.
The next thing I needed help with
Okay.
was regression. That's what I was starting.
Was regression. Okay. Yeah, let's look at regression. So with regression, there are a couple of ways to do this. Now you can use your calculator, which is fine. That's fine. If you do, I have a calculator. Let me see if I have. Let me look at this real quick. I don't know if I have my calculator emulator set up on this computer. I'm going to look. So TI2. I don't think I do. Okay, so there's two ways I can do this. I'm going to show you. I'm just going to get a calculator and use the document camera to show you how to do it on the. Oh man, I wish I had that thing. That's a bummer. I think I wasn't able to install it at home.
Okay.
Yeah, here, let me just grab a calculator and I'll show you how to do this on here. I'm gonna go steal my son's. I'll be right back.
Okay.
Okay. Ladybug. Okay. Oh, there we go. Oh, it's showing it. Oh, that's interesting. Huh. Okay, so it's showing it on. Now, do you see the calculator?
Yes.
Okay. Oh, it's showing it backwards. That's crazy. How do I do this? Oh man, all these crazy issues we're having here. Okay, give me just a second. I'll get this figured out.
Okay.
This is weird. I don't know why this isn't showing up on my. I'm gonna. Okay, let me try this one more time.
Okay.
There. Now, why is it looking all goofy? What? There we go. Okay, I think I got it here. Finally. Okay, so you can see the calculator now?
Yes.
Okay, so here's how you do regression then. So you're going to go turn this thing on, and you're going to go, I got to think here, you're going to go to stat. See the stat button right there?
Yeah.
You're going to go stat, and you're going to go edit. Okay, and then you're going to put your information into this screen. Now, if it's already got information there, here's how you clear. We're going to use columns L1 and L2. Okay, so to clear those out, you just go up to the top. Now, don't hit delete. If you hit delete, it's going to completely get rid of that column. You want to hit clear, not delete. I'm going to hit clear, which is right there. Clear, enter, and it'll clear out all the numbers in that column. Okay. So I'm going to go up to L1, column L1, and I'm going to hit clear, enter. Okay, now what if you accidentally, I'll show you this because you're probably going to make this mistake at least once. What if you hit delete instead and it gets rid of L2? Well, you need L2. Then all you have to do is go back into stat, setup editor. Go down to number 5 and just hit setup editor and hit enter, and it's done. And now if I go back to stat, edit, there, it's got my L2 back. Okay, and then L1 is, that's going to be your X values, and L2 would be your Y values. So give me an example that you're working on in Acellus, like what you want to use regression for what points?
Well, first off, I don't have that. I'm using Desmos.
Okay, yeah, I'll show you Desmos too.
Okay.
Yeah, I'll show you both.
Do you just want the X?
Yeah, give me the X. Yeah, so what's the X value?
1.
1. Okay, what's the Y value that goes with 1?
14.6.
14.6. So I get to point 1, 14.6. Give me another point.
5.
Okay.
5.
5 goes with 5. Okay.
Yep.
What else?
And that was it.
That's it. Okay. And we want to use regression to find the best fit line for those 2 points, right?
I think so, yes.
Okay.
Or it says linear regression.
Linear regression, right. That's okay. So what we do then is once we've got the information in there, now we're going to go back and push the stat button. And we're going to go over to the calc menu, and linear regression is number 4. Right? So I'll just scoot down. I can either just type 4, or I can space down to the 4th row, hit enter. And then look what it says. X list is L1. Okay, that's what we want. Y list is L2. That's what we want. You can skip everything else. And if you just want the answer, you can just go down and hit calculate. Okay, so if I go down and just hit calculate, look what it does. It tells me my best fit line is y equals ax plus b, where a is the number negative 2.4 and b is the number 17. So my answer is negative 2.4x plus 17. Okay. And then you notice it also, it shows me this little r squared down there. That's like the percentage of the fit. So this is a 100% fit. The line fits those points exactly, which makes sense because 2 points defines a line. Now, what if we went back? Like if we went back to our stat screen, and what if I added another data point? Like what if I said something like, what if I add the value 7? Whoops. What if I add the value to 0.73? Okay, and you can't see that very well, can you? That's better. Okay, and we go stat calc. I'm just going to type a 4. And then I go down and hit calculate. Okay, now that time it gave us a different equation, didn't it? We get negative 2x plus 16.2. And this time you'll notice that the r squared is not perfect. If I write that as a decimal, it's about 97% accurate. So it's a pretty good fit, but it's not perfect. Okay, there's one other little trick on the calculators. And I'll just show you the calculators because you may need to do this on calculators like next year, for example. I think Mrs. Jones wants you guys to use calculators for this. I think Desmos is better myself, and in college you'll probably use Desmos now. But you may at some point need to do this on calculators too. So if we go stat calc 4, and if we go down to this store regression equation part, well, we can store this as a y value that we can show the graph. We can show the graph on the calculator, and this is totally optional. So if this doesn't make sense, don't panic. It's not a big deal. Okay. But on the calculators, I just need to put a y1 in there. And then when I put a y1 in there, it's going to be like when I push that y equals to graph something on the calculators, it'll show up in there as an equation that gets graphed. So to find the shortcut for finding y1 is if I hit alpha, which is that green button, and then I go up here and hit F1. Oops, I think it's not F. I think it's over. Maybe it's F2, 3. I forget which one it is. Oh, there it is, y variables. If I hit alpha and then I hit F4, it shows a little pop-up with all the y values, and I'll just choose y1. So now it's going to store it as y1. So it's going to do exactly the same thing it did before, but now if I go up into my y editor, there it is, right? And so if I go down and I hit like zoom standard just to get the normal screen and I graph it, there's my line. Okay, what might even be better here? Well, okay, does that make sense?
Yeah.
Okay, so there's the line if I actually want to use it. One more little thing, and I don't want to overwhelm you, and you're probably going to like the Desmos one better anyway. Okay. But if I go up to, I'm in the y equals menu. If I go up to plot 1 and I turn that on and I hit graph, you're going to see the data points of your data displayed on there. Okay. And if I want to have the window show all of the data points that I entered, I can go up to the zoom menu again and I can go down and hit zoom stat, which I think is 9. Yeah, zoom stat. And now it'll size the window on the calculator so it spreads out all of the data points that I entered, and there's my line. So you can see it's a pretty good fit. Okay, does that make sense?
Yeah.
Okay. All right, so then let's do this on Desmos because you're gonna like Desmos better. So on Desmos, here's how you do it. So we've got to make a table first of all. So we're going to hit the little plus sign here, and we're going to go down to table, and then there's my X1 and my column X1 and column Y1. So instead of L1 and L2, they call it X1 and Y1, but we're doing the same thing. We're just plugging in our values. So yours were, see, we had 114.6.
Yes.
And then we had 5.5.
Mhm.
Okay, so well, one thing, look what it does. It shows you right away. It graphs those 2 points, which is kind of nice. If I want to get the regression equation, I come down here and I'm going to say, okay, I want to figure out how is Y1 connected with a line to X1. And so the form of a line that we probably want to use here is just Y equals MX plus B, right?
Mhm.
Okay, but instead of Y, we have to call it Y1 because the data points are in column Y1, the Y values, and the X values are in X1. So I'm literally just going to type Y1, and it knows to put the 1 as a subscript. Okay, now Y equals MX plus B, but when we're doing regression, we don't use equals. We use a tilde, which is up to the left of the 1 on your keyboard. Okay, so we hit shift tilde. And that little symbol right there means is regressed against. So it's building a regression equation when we do that. Okay. And now I just need to tell it what kind of regression equation do we want? Well, we want M times X1 plus B. Okay, and then what Desmos automatically does, and this is super cool, Desmos automatically understands that, okay, we want to fill in values for M and B. We want to know what are the best values of M and B. And it tells us M is negative 2.4 and B is 17. Okay, and it actually graphs the regression equation over here.
Okay.
Okay, see how that works? And look, R squared is equal to 1. So if we go up to our table up here, and let's say we wanted to fit 3 points instead of 2. Now, 2 points fits exactly with a line, so it's 100%. But we said, I think the point 7.3 or something like that, didn't we?
Yeah.
Let's do 7.3. So now look what it does. It changes the regression equation a little bit, and it makes it not quite perfect anymore. Okay, like if I had the point 7.13 instead of the point 7.3, it wouldn't have been a very good regression equation. The best fit line, now look at the R squared. That's only like 11.5% accurate. It's a terrible fit. Okay, but there is really no good line that's going to connect all 3 of those points anymore.
Mhm.
See how that works?
Yeah.
Okay, well, let's do one that's not linear. Okay, so do you have one from your assignment that's like quadratic or cubic or something?
No, not yet.
Not yet. Okay, well, let's make one up.
Okay.
Let's say we've got these same 3 points, but I want to make this fit this to a parabola. Okay, well, what form of a parabola do you want to use? How about just ax squared plus bx plus c? Does that make sense?
Yeah.
Okay, that'd be standard form for a parabola. So then instead of saying y equals ax squared plus bx plus c, we're going to do y1 is approximated by, right? So we're going to use the tilde. We're going to regress this. A x1 squared plus b x1 plus c. And look what it does. It fits it perfectly to a parabola because it turns out that 2 points defines a line, 3 points defines exactly one perfect parabola. And look what it tells me. It tells me the values of all of the coefficients. So the perfect parabola there would be the one. And let's go ahead. We'll go ahead and graph this. It's a different color. Y equals 1.06667 x squared minus 8.8x plus 22.3333. And what do you know? Look, it sits right on top of, that's the equation. You see that? That's the equation of that parabola that it gave us. It fits those points perfectly. And if we added an extra point up here, like let's just say we added the point like 0.20 or 0.16, how about?
Mhm.
So it's on the screen. Well, now the best fit parabola doesn't actually go through any of those points, and it's really, you know, it's not a bad fit, but it's not great. If you look over here, it's only about a 75% accurate parabola, right?
Mhm.
You look at the R squared right there. Okay. Does that make sense?
Yes, it does.
Okay. Want to do another one, or you think you got it?
I think I got it. Thank you so
Okay.
much.
Yeah. Oh, that's no problem. No problem. I'm glad I was able to help. All right. Well, email me if you have other questions, Haley.
Okay, thank you.
You
Bye.
betcha. Have a great day.
You too.
All right. Bye.